This is my Regal DS2302A digital oscilloscope, ultra version 2 channel, 300 MHz, 2 gigasample per second. This oscilloscope is a good oscilloscope for the beginners. So you can see in the screen there is no signals inputting for the oscilloscope. This oscilloscope has two channels, channel 1 and channel 2. This is the external trigger channel. So currently both channels are turned off. You can see if I turn on this channel 1, the channel 1 comes up in the screen, and if I turn on channel 2, it's magenta color, it also comes on the screen. So both channels are seated in the same x-axis, so it's just overlapping each other. So here is my KK Moon FY6900 100 MHz function generator. Currently I'm outputting 0 Hz from this function generator. This function generator has two channels, channel 1 and channel 2. Same as the oscilloscope, I can turn off the channel 1, you can see, and then turn off the channel 2, the same. So the channel 1 goes to oscilloscope channel 1 input, and channel 2 goes to oscilloscope's channel 2 input. So just I turn on the channel 1 on from the function generator, and then you can see channel 1 outputting sine wave 0 Hz, but I'm changing the frequency from here. The frequency I can change from here. Just I can change the unit, so Hertz. So I am moving this indicator to, so now the function generator is outputting 1 Hertz, and then I can see in the oscilloscope the 1 Hertz is being taken from the oscillators. So I'm changing the frequency. You can see 2 Hertz, 3 Hertz, 4 Hertz, 5, 6, 7. So now from channel 1 and channel 2, both channels being input 10 Hertz. You can see only the channel 2 because the channels are overlapping each other. So for better understanding, I'm just moving vertically little bit channel 1 down from its current position. You can see the same phase, same amplitude for both signals. That's why we didn't see the channel 1, because it's underneath the channel 2. So what is Lissajous figure? From this oscilloscope I'm changing the domain. This is now in time domain. In y-axis the voltage, and in the x-axis is the time. So I'm changing its base from YT mode to XY mode. So you can see in X and Y position, you can see that something is in 45-degree angle to the axis, x-axis is just up and down. For more clear, I'm just changing all this frequency, channel 1 frequency to now the channel 1 frequency is 1 Hertz and channel 2 frequency is 10 Hertz. So I'm also reducing the frequency of channel 2. You can see channel 2, I set the channel 2 for 0 Hertz. So channel 1 from the function generator, it's outputting the frequency of 1 Hertz. So that's why just the indicator on the screen is just moving left and right in 1 Hertz. That means one time per second. If I change the frequency for channel 1, see the difference. I change the frequency 2 Hertz, 3 Hertz, 4 Hertz, 5 Hertz, all the way up to I change it, you see I change it 50 Hertz. You can see from the oscilloscope also this is 50 Hertz. So as this is much faster, left and right moving much faster, that's why our eyes is not able to see the moving difference. So it just our eyes just seeing just a horizontal line in the x-axis. So I turn off this channel 1. I turn off the channel 1, and let's see from channel 2. I turn on the channel 2. I'm turning on the channel 2, and from this channel 2 I'm just increasing the frequency from 1 gradually from 0 Hertz to 50 Hertz. Let's see what's happening here. So I just increase 1 Hertz. You can see now from the channel 2 is feeding the signal from channel 2 from the function generator, and this channel 2 makes the indicator up and down in y-axis. So when I set up the time base XY mode, and this the functions of the screen, you can see like this. And if I just change the time base to the roll mode, and you can see the channel 1 is 0 volt, there is no frequency, and channel 2 is 1 Hertz per second. So I'm changing the mode again, going to XY mode. So now if I increase the frequency, it's up and down, it's getting much faster, much faster. 20 Hertz, 23 Hertz. So when I'm increasing the frequency from its lower position to higher, so you can see there is a line overlaying on the y-axis, and this is works like this. Remember, there is no input for channel 1. You can see all the inputs for channel 2 only. So what's gonna happen if I turn on both channels of the oscilloscope and at the same time I supply some frequency, the same frequency from this function generator, and what's gonna happen? Let's see. So currently this frequency is 50 Hertz. This frequency is 50 Hertz. So I'm turning on channel 1. I'm turning on channel 1, and channel 1 I also set up 50 Hertz for channel 1. You see in the screen there is a 45-degree angle bar with the x-axis. So now I'm channel 1 frequency I'm reducing. See the change. Channel 1 frequency is 0 Hertz, 1 Hertz, 2 Hertz. So I'm increasing the frequency now. I'm going to up to 50 Hertz. When when this oscilloscope see the same frequency in both channel and same phase in both channel, then it will make a 45-degree angle to the x-axis like this. Now both channel are same frequency, same phase difference. So there is no phase difference between these two channels, and there is no frequency difference between these two channels. So that is why the Lissajous figure is on the screen 45-degree angle. So let's see, I'm changing the phase from this function generator. (1°), changing the phase 1 degree, and we just observe the roll mode, YT mode. 1 degree is nearly not noticeable. I'm changing more. You can see the phase difference for channel 1. The phase difference is 4°. So phase difference between two channels is 4°. Phase angle is 4° for channel 1. I'm increasing the phase angle for channel 1, and that's why the channel 1 wave is just lagging behind the channel 2. So let's see what is in this XY. So 40° phase angle, what's happened? This is 60° phase angle, increasing. 82, 87, 89, 90. So when I hit 90 degree phase angle for channel 1 and 0 degree phase angle for channel 2, the Lissajous figures showing a circle. This looks like same radius for this circle. When I increasing the phase angle for channel 1 and just I'm going to 136 degree, 170 degree, 180 degree. So this is 180 degree position, phase difference position from channel 2 to channel 1. So channel 2 is 0 degree phase angle for this supply signal, and channel 1 is 180 degree phase difference from this channel 2. So when the input signals phase difference is 180 degree, the Lissajous figure shows like this. It's like the second quadrant in the XY coordinate system and fourth quadrant. So this is 180 degrees 80 degree phase angle difference between two channels. So I'm increasing more for channel 1 phase difference 220. I'm gonna see another circle when I'm hitting 270 degrees Celsius. It looks like 90 degree phase difference when I was before moving from 0 to 90 degree phase difference for channel 1, and it's the same shape, same circle it's showing us when I'm hitting 270 degree phase difference for channel 1. So again I'm increasing. This is gonna make a shape like 0 degree phase difference when the phase difference for channel 1 is 360 degree. This is 359.999, that means 360 degree. So in that position I can see the same shape when I first started, when both channels were in the same phase difference, that means 0 phase difference. So now if I actually don't know the inside happening, what is happening, maybe I can think this is 0 degree phase difference, 0 degree phase difference in channel 1, 0 degree phase angles in channel 1. So I'm just seeing in the time-based mode. Now you can see there is no phase difference, it just messed up. You see, it just overlapping each other. Actually from the function generator I can see there is 360 degree phase difference between two channels, though the screen shows from the oscilloscope there is no phase difference between these two channels. Why? Because it's just overlapping each other in a certain time period. So I'm changing the phase angles for channel 1 down to 0 and going to XY mode. You can see now is 0 phase angles, 0 degree phase angles for channel 1. So this is the Lissajous figure, we can say. So I'm showing some interesting shapes I just increasing the frequency for channel 1 like few kilohertz, like 1 kilohertz. You can see the shape for channel 1 is like this is 1 kilohertz for channel 1. When I increasing the frequency, you can see 2 kilohertz, 2.7 kilohertz. The shape is changing. 5 kilohertz. This is a nice shape. You can see this is a very beautiful shape. So I'm changing the channel 2 frequency from 50 hertz to higher. It's just much faster. I'm just changing the frequency for channel 2. You can see now this is 100 hertz for channel 2, and for channel 1 is like 9200 hertz. For channel 1 I'm making it like 10,000 hertz. This is 10,000 hertz for channel 1. For channel 2 this is 100 hertz, 200, 300, 400, 500 hertz for channel 2. This is another stable state for channel 1 and channel 2. Looks like beautiful. Increasing the frequency for channel 2. Three kilohertz. Going to all the way to 10 kilohertz, and you can see the difference when this is matched. I can see when this will be the same frequency with the channel 1 like 10 kilohertz, because I'm gonna see the 45-degree angle line to the x-axis when both frequency matches each other. So yes, now this is the 10 kilohertz for channel 2, and then I found this line. So you can see from this function generator, channel 2 is 10 kilohertz and channel 1 also 10 kilohertz, and that's why it's just matched. It just makes a 45-degree angle line to the x-axis. So that is, I think, the main purpose of Lissajous figures, to see the difference between two channels. Sometimes it's very needed for circuits network analyzing from input and output signals, and to see what's the difference between input and output signals of the circuits. So that's why the XY mode is very important at that moment. So that's it for, I think you guys enjoy the video. Thank you very much.